For my horror game, I wanted to create a new puzzle mechanic that would appear throughout the game with different levels of difficulty. While browsing the web for an old CRT for my flat, I came across a few broken ones. I asked myself, should I buy one and try to repair it as a fun side project? That's when I had an idea. What if I could turn a CRT inside my horror game that players had to adjust to solve a puzzle? I realized that I hadn't seen a game use this kind of mechanic before. The only thing I could think of were audio frequency puzzles in games like Myst. But those often felt a little bit abstract, as you mostly just had one line wobbling over your screen. An old CRT TV, on the other hand, could enhance this riddle by showing an actual image. I wanted the player to actually get the feeling of playing around with the knobs of a CRT. Just like in real life, you twist them until the picture suddenly shifts and gives you a clue that you're on the right track. So my first step was to look for visually interesting CRT effects. For the puzzle design, I thought that 3 knobs would be enough for the players to adjust. The first one was a channel selector. If the player set it correctly, the image would shift from pure white noise to a clear signal. The second one was a vertical roll, where the image slowly drifts up or down on the screen, like the sync is off. The last one was a horizontal roll, where the image shears and moves sideways. To realize the CRT puzzle, I needed to work on 3 points: the shader effect, the CRT model, and the coding of the interaction. Before touching the last 2, I started with the shader, just to find out if the mechanic was actually entertaining. When I started working on the shader, I made a list of all needed visual components to make the CRT effect feel authentic. I came up with these: fading from white noise into an image, letting the picture roll vertically, letting it roll horizontally, visualize the picture being made up of single pixels, animating the TV turning on and off, and finally adding small details like distortion, scan lines, and a fisheye effect. I should mention I'm still quite new to the shader development, so this was also a project to get myself more familiar with it. Also, it may have become quite bigger than I first anticipated. For fading from a white noise image to the actual image, I started simple with Unity's built-in noise node. By connecting it to a time and a random range node, the noise pattern would keep changing randomly, creating that static effect. Then I added a channel tuning property for the player to control and an image texture property that should be later displayed on the TV. With the channel tuning property, I could blend between the white noise and the image texture. To make the interaction feel more alive, every time the player changes the variable, the noise flickers brighter and darker. Next, I worked on the vertical roll effect. I started by creating a property called vertical speed, which I multiplied with time. This value was then fed into the offset of the UV coordinates. When vertical speed was set to 0, the image would stay perfectly still. But during testing, I noticed a problem. Whenever I changed the value of the property, the image jumped abruptly. So I made some changes and used a modular node to prevent high values. This way, the roll felt smooth and consistent. The only downside was that the picture would jump for lower values of the vertical speed property, but I thought this was an interesting look and kept it this way. After that, I moved on to the horizontal roll. I began with a property called horizontal speed. First, I implemented the horizontal movement, similar to how I did the vertical roll. Next, I created a simple horizontal scaling by multiplying this property with the UV's x coordinates, while leaving the y coordinate untouched. Afterwards, I added a small sinus wobble distortion that moved vertically over time, also influenced by the horizontal speed value. Finally, to give the picture that displaced CRT feel, I added a shear effect, so the image would slightly tilt and shift. For the pixelate effect, I found a really cool YouTube tutorial by ADJUSTABLE. I put the link in the description. The idea is to first pixelate the base image. Then the resulting image is split into its separate RGB values. Each of these values is used to generate tiny rectangles that represent single pixels, showing the color intensity for each color channel. Next, I wanted to recreate the classic CRT power on effect. The idea was that the image doesn't just appear instantly, but grows from a small oval into the full screen. To do this, I created a property called time since TV power on. With this value, I generated a circle mask that increases in size over time. By applying different factors to the horizontal and vertical values, I could stretch the circle into an oval, making it look more like the real startup of an old CRT display. To make the image look even more like an old CRT, I added several subtle effects. First, a slight fisheye distortion, bending the screen just a little. Then I created horizontal distortion lines that slowly wander vertically across the screen. Finally, I added noisy vertical lines that drift over the image. With all these components combined, it was finally time to test the CRT shader. And I really liked the result. With the shader out of the way, I could move forward and create the actual 3D model and textures for the CRT. I started the model as a basic cube, assigning placeholder materials to different meshes and adding simple buttons for the player to interact with. Then I imported it into Unity to check the scaling and proportions. Using several reference pictures, I modeled the TV to look like it came out of the 1940s. For this workflow, I began with the low poly version first, then duplicated it and created a high poly model out of it. Afterwards, I added an armature setup for the knobs so they could later be animated when the player interacts with them. The next step was adding textures. For this process I used Substance Painter. I decided to give the TV a wooden casing with metal and plastic parts to make it look authentic. Afterwards, I added details like engraved text, brand markings, and control panel details. Now the coding of the mechanics started. Since my game is already in a later stage, I had most of the basic interaction scripts working. Of course, that didn't mean I wasn't constantly running into old bugs that I had to fix first. Basically, the player can use the W and S keys to select a button, and then use the A and D keys to adjust its value. I also added an option to disable certain buttons. This way, I could introduce the CRT puzzle gradually. At first, only the channel button is active, but later in the game, players need to adjust all of them. Additionally, I implemented sound sources that give players hints by playing TV audio when the channel is tuned correctly. As a final step, I added Unity's video player component. This allows the TV to play actual videos instead of just showing static images, and a surveillance camera setup that could render its feed directly onto the CRT. This keeps me flexible for future gameplay ideas. I don't know exactly how the CRT will be used in the later stages of the game. Maybe you have some ideas. Let me know in the comments. So that's how I created the CRT TV in Unity. Thank you all for watching. If you enjoyed this video, I'd really appreciate it if you give it a like or even subscribe to the channel. Thanks a lot and see you next time.